Okay, let's take a look at homework 5, question 14. This one's asking us to find the points on the graph of f where the tangent line is horizontal, and they give us f of x equals x over x squared plus 1. This problem is very similar to question 8, so if you're really shaky on the process, I really recommend going back and watching the video for question 8 again, because the only difference is the way that we take our derivative here. We have to use a different rule than we did for number 8, but everything else in this process is the same. So these videos kind of go hand in hand. So they want us to find a point on the graph of f where the tangent line is horizontal. If we need to find the formula for the tangent line, we are going to have to take the derivative. And in this case, if we want to take the derivative, if we want to find f prime of x for the quotient rule, or f prime of x, we're going to have to use the quotient rule. That's because we've got an x on top and we've got an x on the bottom, so technically these are two separate functions and we have to use the quotient rule. And to do that, you take the bottom function, so we'd take the bottom function and multiply it times the derivative of the top function, so the derivative of this guy, and from that we subtract the top and multiply that times the derivative of the bottom. And we put all of that over the bottom squared. And so you can remember it that way, that's the rule, but you could also think of it, I've done this in a few of the prior videos, the way that I learned it in Calculus 1 was low d high minus high d low over low low. And it's kind of got a sing-songy thing going to it, low d high minus high d low over low low. And for me that was easier than remembering it with all of the formal terms. But however you remember it, you're going to have to use it here. So let's go ahead and do that. So we need the function on the bottom first, so that's just going to be x squared plus 1. Then we need the derivative of the top. Well, the derivative of x, that is 1. Now we need to subtract what's on top, so that's x multiplied by the derivative of the bottom. So we're going to use the power rule here, that's going to give us 2x. And the derivative of a constant is 0, so that doesn't add anything to that. And we put all of that over the bottom squared. So x squared plus 1 squared. Okay, I think we could do a little simplifying, so let's go ahead and do that because it's going to make our lives easier in the long run. So let's see, we've got x squared plus 1 times 1. Well, that's just x squared plus 1. Minus x times 2x. That's 2x squared, and then we still put it all over this x squared plus 1 squared. And we can simplify it even further. That's the same, let's see, x squared minus 2x, well that's negative x squared plus 1 over x squared plus 1 squared. Okay, so we've got our derivative. This is a derivative. There isn't even a blank to fill in for the derivative at this point, so you have no way of telling whether it's right unless you followed these steps and then you know that it's right. But what we need to do now is find the graph of f or find the point on the graph of f where the tangent line is horizontal. A horizontal tangent line has a slope of 0. So this right here, this f prime of x, is the formula to find the slope of the tangent line, and we want to know where that slope is 0. Slope is 0. We need to set this equal to 0 and solve for x, and that's going to tell us any place that the tangent line is equal to 0. So let's grab another sheet of paper. I feel like from this point on, we hope that it's going to be really straightforward, but in this case it's not quite that straightforward, but it's not bad. We can figure it out. So we have f prime of x that we figured out in the last step, and that is negative x squared plus 1 over x squared plus 1 squared. Okay, so we need to figure out everywhere that this function is equal to 0. Something that they say in the question kind of throws you off because they're saying if an answer doesn't exist, enter DNE. Okay, the last time we saw that was when we were trying to set our denominators equal to 0. because we would have issues with functions not being defined if the denominator equals 0. Well, I've got fantastic news for you. That cannot happen in this function. There is no way that our denominator can be 0. That's because for our denominator to be 0, this term right here, this x squared, would have to equal -1. And you can't have a number that's squared equaling a negative number. If that was a -1 for the x and you squared it, it would be -1 times -1, and that would be positive. There's no way to get a negative number here, so we can't get a 0 in the denominator. So we don't have to worry about that. That's just not an issue here. So what do we want to know? We want to know where this equals 0. Well, where does a fraction equal 0? What kinds of fractions equal 0? They're fractions where there's a 0 in the numerator. So we don't even care about this denominator anymore. We just want to find all of the places where x squared plus 1 equals 0. So we're just going to solve this for x. So that means, well, negative x squared, I'm sorry. I wrote it, I didn't say it out loud. So that's negative x squared equals -1. So I guess we could cancel those negative signs to make our lives a little bit easier. We need all of the places that x squared equals 1. Well, there are only 2 of those. There's not a whole lot of math here. We take x squared, x could be -1, right? -1 times -1 is +1. And x could also be +1. +1 times +1 is +1. Those are the 2 things. We kind of just did plus or minus the square root of 1 here. So we got -1 and +1. So what do we do with those? Those look like x values to me because we said it was x. So we need to figure out the y value for these points because it's asking you for x and y. Now, you might be tempted to plug these back into this guy up here, but that's not what we're asking for. We're not asking for the point x, y in our derivative function. We're actually looking for the point in our original function. So we're going to have to plug those numbers, the -1 and the 1, back into our original function. So I will write down the original function, and that was x over x squared plus 1, and we're going to need f of -1, and we're going to need f of 1 for this. So, and also remember that f in these functions, that's the same thing as y. Y equals whatever is on that. Y and f of x are the same thing when we're talking about functions. So if we need the y coordinate, we just need to find f of these values. So this is -1 over -1 squared plus 1. Use the parentheses here. Otherwise, you're going to have a negative sign hanging out. And that is -1 over 1 plus 1. So that's 2. So for this one, if x equals -1, y equals -1/2. So there is one of our answers. This is x, this is y, and this arrow is apparently for a comma. Don't know why I drew that one. Okay, so let's do it for f of 1 really quickly. We've got 1 over 1 squared plus 1. Well, that's 1 over 2. So we have +1/2. So when f is 1, y is +1/2, and that's our other answer. And they're asking you in this question to use the smaller x value first. So that's going to be the -1, and then the larger one will be the +1. So for the first blank, you would just fill in -1 and -1/2, or -1 comma -1/2, and for this one, you'd fill in 1 comma 1/2. Those numbers might be different depending on what function they gave you, but the process is still the same. So this was a bit of a long one. Let's walk through it really quickly before I let you go. We start with the function that they gave us. We need to take the derivative. We do that using the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. We basically filled in the blanks for that, simplified, and found our answer. Then we needed to find the slope of a horizontal line We know that we want this line to be horizontal, so we needed to set this guy equal to 0. We set this guy equal to 0, figured out why the denominator didn't matter for this particular function, and then we set the numerator equal to 0 and solved it. We got 2 answers. We take those answers and plug them back into the original function. Original. Not into the derivative. Because if you plug those back into the derivative, you're just going to get 0, and that's not going to be good. Actually, in this case, you might not, because you have some other stuff going on in the denominator. Either way, you're only going to plug this into the original function, so you find f of the first x value, f of the second x value, and since f of x is y, that gives you your y values for both of your answers. Lowest one gets entered into WebAssign first, because that's what they ask for. Second one gets entered in after, and hopefully you hit submit, get a beautiful green check mark, and go on your merry way. If something doesn't work out for you, check out question number 8 if it's the whole figuring out where the slope is horizontal. If you're having issues with the quotient rule, you could check out question 12. There's a video for that that goes through the quotient rule in a little more detail.